Welcome to Study Loop.
Okay, folks, so in this video we're going to be talking about this problem. At one instant, this velocity, negative 2I plus 4j minus 6k meters per second, is the velocity vector of a proton in a uniform B field given by this vector. At that instant, what are part A, the magnetic force, F acting on the proton in the unit vector notation, and part B, the angle between V and F, and part C, the angle between V and B. Okay, so basically we're given the fact that we have a proton moving in a uniform B field, and we're also given the velocity of this proton. And what we're looking for is the magnetic force acting on the proton as a vector. And we're also looking for the angle between the velocity and the magnetic force. And we're also looking for the angle between the velocity and the B field. So first of all, we can knock out part B very quickly, because if you recall, I just want to remind you that when you have a particle moving with a velocity in a B field, it's going to experience a magnetic force given by this formula, F equals Q V cross B. And as you can see, this is a cross product between V and B. And if you don't remember this, I just want to remind you that that the result of a cross product is actually perpendicular to each of the two vectors that goes into the cross product. So F, as the result of the cross product, is going to be perpendicular to both V and the B field. So that's really the answer to part B, because F is perpendicular to V. That means that the angle for part B is going to be 90 degrees. That's just a general property of cross products. So if this is the velocity vector, this is the B field vector, and you do your cross product, you will find that the force vector is going to be pointing straight into the page. Okay, anyway, so that's for part B. And part A is going to use this exactly the same formula, F equals QV cross B. And what we're going to do for part A is we're going to actually carry out the procedure for determining a cross product. In other words, we're going to be doing QV cross B, which is equal to Q times the determinant. That looks something like this: I hat, J hat, K hat, and then we put V in this row, and then B in this row. Okay? So V is -2, 4, -6, and B is 2, 4, 8, right? After you're done carrying out this procedure, you will find that that the force is going to be 1.28 times 10 to the power -21 newtons in the x-hat direction, and 6.4 times 10 to the -22 newtons in the y-hat direction, and 0 in the z-hat direction. Okay, 0 in the z-hat direction. Well, before you get this result, we're assuming that you already know what the charge of this particle is, and that's not hard to find out, because we know that the particle is a proton, and the charge on a proton is just 1 e, and that also happens to be the same amount of charge on an electron, but with a negative sign. Okay, but anyway, so this is for part A. And this is for part B. Now we're going to be looking for the answer to part C. What is the angle between V and B? Okay, so we're given the velocity vector for V and B, and all we're doing is we're determining the angle between V and B. Now, there's many ways to do it, and one of those ways is by recalling that F equals QV cross B, and that means that the magnitude of this whole thing is going to be the magnitude of this whole thing, and we know about the magnitude of the force because we know the force, and the magnitude of it is just going to be the x component of the force squared plus the y component of the force squared plus the z component squared, but the z component is 0, so we're just going to ignore that. And this is going to be equal to q vb sine theta, where v is the magnitude of the velocity vector, so that's given by vx squared plus vy squared plus vz squared. And same thing with b, where b is given by bx squared plus by squared plus bz squared. And you can find the bx, by, and bz by looking here. And you can find vx, vy, and vz by looking here. Okay? And after you calculate the magnitude of the velocity and B field, you're going to plug those things in here, and we can find an expression for sine theta, which is the magnitude of F divided by Q V B. Now, the answer is very clear because theta, which is the angle between V and B, is just going to be sine inverse of F over Q V B. And if you have plugged in all of the numbers into your calculator, you will find that the theta is actually going to evaluate into 172.5 degrees. This is the numerical result. What I have shown you is a symbolic set of expressions. I did not bother to plug in the numbers because that's trivial. When you're done plugging in the numbers into your calculator and actually evaluate this expression, you will find this angle. Okay, so we're done finding the answer for part A and part B and part C, and we're done for this whole problem. Okay, thank you very much. See you in the next video.